Hello and welcome to Geography. We're going to start with Chapter 1, Objectives and Tools of World Regional Geography. As you can tell by this somewhat funny comic, this class is not intended to be simply a memorize all the rivers of Kazakhstan sort of geography. Rather, we're going to utilize geography in a way to better understand the multifaceted world in which we live in. In order to understand geography, you need to start with when it started. Geography was first used and developed by a Greek scholar called Eratosthenes in the 3rd century BCE. Literally, it means a description of the earth. We could sum it up in two different branches, physical and human geography. It would not be wrong to think of geography as sort of a jack-of-all-trades study. All human and physical geographies, all social and physical sciences, in essence, are small pieces of what geography studies as a whole. The 6 essential elements of geography that we're going to focus on in this class include the world in spatial terms, places and regions, physical systems, human systems, the environment and society, and of course the various uses of geography. Within these 6 essential elements, we also find 5 predominant themes, those being location, place, the human-environment interaction, movement, and of course, the overall region in which we talk about. This image encapsulates the way the 5 themes of geography can be used to describe something. You of course can describe its rote location or its region, but knowing the movement behind it, or possibly the human-environmental interaction involved with what you're talking about, gives you a better understanding of not only the history, but also the significance of any particular place, location, event, etc. The physical and cultural geographies of the world coupled together to influence and adapt the many pressing problems we face in the world today, such as climate change, population growth, and of course hunger. The text we use in this class divides the Earth into 8 world regions. These regions are chosen by the text, and they're not necessarily strict definitions that anyone would agree to. In fact, most geographers use a variety of definitions of region to get what they want. Notice here in this picture, how would you describe the American South? Is it just the Confederate States? Is it things that are south of a certain line? Is Oklahoma a southern state? It depends on how you want to define southern, and that's the point of this conversation. Here are the regions this text covers: Oceania, United States and Canada, Latin America, Sub-Saharan Africa, Middle East and North Africa, Europe, Russia and the near abroad, and South and East Asia. Again, these are not strict definitions and required regions. It's simply how the text wishes to break apart the world. This is an example of a chart we're going to see a lot in this class. A basic data chart describing what's going on with the region we're talking about. In this case, we can see area, population density, human development index, urban population. We'll go more into depth about all these charts and all these statistics as we go through the class naturally. Of course, it is important to note that these charts are not necessarily 100% up to date. For example, this one's from 2011. So why was this text written? Well, the objectives of this book are fourfold. 1. To understand Earth's problems and potential solutions for these problems. 2. To develop a habit of synthesizing information to understand the world. 3. To understand current events, again current in the context of when the book was written. And 4. To develop the ability to interpret places and quote-unquote read landscapes. I will dive a bit deeper into these than the book necessarily intends, because I want to make this applicable not only to this class, but maybe a bit into the way that you look at the world in general. On the topic of interpreting or reading a landscape, we can take a look at this picture. Look at this picture and ask yourself, what's going on here? Who is this person? Where is this located? Can we understand certain things about not only the place, but also the people involved just from this picture? I can look at this and I can see a few things. He's on horse. It looks like a desert, right? He's wearing a bolo tie. His skin tone is a bit darker. He's wearing a cowboy hat. All these things led me to a certain conclusion, right? I'm not looking at this and thinking I'm looking at a picture of Finland here. When you look at a map, it's important to understand what the map is conveying. A map is in general, 2D representation of something that usually is not actually 2D, right? The world is not two-dimensional. We use maps because they're easier to carry and look at than, let's say, a globe, for example, which would be a 3D representation of something. Maps are very much the essential tools used by geographers. The art and science of making maps is called cartography. Most maps you're going to see help you understand the spatial context of what you're looking at, i.e. what is next to what. Maps have very common elements between them, such as a scale, coordinate systems, projections, and of course symbols. The scale of a map represents the size ratio the map is giving you. For example, a 1 to 10,000 scale means that one unit of whatever the map is measured in, inches or centimeters usually, represents about 10,000 of the real world unit, miles, kilometers, for example, that's being shown there. You have large scale and small scale maps. A large scale map is a large representation fraction that allows you to show smaller area. So each unit on the map is a smaller unit in real life. A small scale representation, conversely, shows a large area. So a small scale map would be a country, a large scale map, of course, would be a city, for example. Here we have a small scale and large scale map representation of San Francisco. Notice the small scale map shows you not only San Francisco, but its outlying suburbs, whereas the large scale map zooms in very much to a street level. A 1 to 1 million versus 1 to 10,000 comparison. Coordinate systems are what allows you to find something on a map. They come in two flavors, relative and absolute coordinate systems. Coordinate systems tend to be grids of horizontal and vertical lines covering what you're talking about. Intersections of these lines create the address that you're looking for. Latitude and longitude would be common ones you've heard for the globe, but they can be subdivided into minutes, seconds, and degrees. The latitude system used on the globe sets 0 latitude at the equator. You can then go up and down the globe 90 degrees. The North Pole would be 90 degrees north of the equator. The South Pole would be 90 degrees south of the equator. Longitude divides east to west along meridians. The prime meridian, or 0 longitude, runs through the Royal Astronomical Observatory in Greenwich, England. Why is it run through England? Because that's where it just runs through. We'll dive deeper into the history of Britain and why, for example, this particular spot in England is considered 0, and it'll make more sense as this class progresses. The international date line would be the opposite side of the prime meridian, and it separates where days begin and end. Here would be a map representation of the parallels of latitude, north to south, northern and southern hemisphere, and the meridians of longitude, east to west, or the eastern and western hemispheres. Just because latitude and longitude are the two most common ways to subdivide the Earth does not mean they're the only ways. For example, here, what if we divide the Earth based on land and water amounts? The land hemisphere has the majority of the land area, and the water hemisphere, conversely, would have the majority of the water area. Take a few moments to pause the video and see if you can find these 4 city locations based on the latitude longitude coordinates. Once you think you've got it figured out, Google it, see if you were correct. We've already discussed how maps are simply 2D or flat representations of the real curved globe Earth. The fun part about that is you cannot 100% accurately flatten a globe out into a map and have it look not funky. You take metric relations on the globe, area, shape, distance, direction, and you contort and change your map to fit what you want. If distance is the most important aspect you care about for a map, you're going to have a different, what we know as projection. Projections are ways of depicting the curved surface of the Earth on a flat surface such as a piece of paper. In this case, obviously a map, right? Common map projection families include azimuthal, cylindrical, and conical. We'll get more into those as we go. Here are 4 very common map projections. A, here we have the azimuthal projection, or the North Pole azimuthal equidistant. What does that mean? Well, that means we're going to keep the azimuths equidistants, or the latitude lines. Notice the squares are within the same amount of distance from each other. However, this doesn't give you a true representation now, does it? Notice North America is really squished in compared to South America, and Antarctica is the largest thing on the globe. These things we know to be false. We can, however, go to the cylindrical map projection, B. This one takes all the lat longs and forms them into squares. Again, we have an issue here where this is going to distort and change the sizes of things. Again, we can look at Antarctica. It's a third of the map. That's not true. You could take a pseudo-cylindrical projection, such as this C, this sort of oblong egg-shaped map, and you're noticing how sizes are changing, things are starting to look a bit better. Greenland has shrunk quite a bit to be more accurate to its size, for example, but it doesn't quite look good. If you want to look at Alaska, for example, you're not getting a lot of detail on this map. We can take it over to D, a conical projection. This is useful because it spreads out and it keeps your distances very accurately. Alaska is of correct size proportion to North America. However, we have to zoom in on something in order for this map to be of any shape useful. If you want to make this map to be the size of the globe, it's going to be ridiculously huge, right? E, we have a polyconic projection. This one keeps the equator flat, so things around the equator look very nicely, and skews things that as they get further from the equator, and it kind of looks weird, right? Finally, we go to F, an interrupted projection. This one does a very good job of keeping sizes of the continents set, but it gives you gigantic holes where the ocean would fit. You can see by looking at these various projections that you can't get a good one-to-one globe to map projection. It simply does not exist. You need to choose a projection that most adequately gives you the information you're looking for. As shown in the previous slide, all maps need to lie in some way, shape, or form and present as much information as possible. Maybe they lie about the particular size of things near the poles. Maybe they lie by having giant swaths of white where the ocean would be. This is again because a globe is a three-dimensional object and a map is a two-dimensional object. You're losing a dimension of information there. So, when you look at a map, you need to figure out what do I want to know and what map will tell me what's important. Perhaps I want a reference map. This is concerned with locations of various features on the Earth's surface and the representation to each other. This is going to tell me different information than a thematic map, which has a theme to it that it cares most about. Here we have an example of a reference map. This one would be of Europe. This reference map wants you to pay close attention to a few things, namely the sizes and relative locations of the countries. It also happens to have information such as rivers and mountains on it, as well as both capital cities and smaller cities. My question to you is, stop the video, can you figure out what all these features are? Notice there is no legend here to tell you what a river looks like, what a sea's name is. How many different pieces of information can you pull out of this map? Here, instead of a reference map, we have a thematic map. Notice it's missing lots of the features of the reference map the previous slide. There's no cities, there's no rivers, heck, there's no country names. Instead, this has a theme, in this case, per capita gross national income and purchasing power parity. This is a map that shows you the theme of more and less developed countries. Here we can look at the legend here and see the bluish and greenish countries are your richer, more developed countries, and your yellow going down to red are your less developed, poorer countries. This map has a very different purpose in mind when you look at it. Again, take a few seconds, pause the video, take a good look at this map. What is something interesting it tells you? Here we have a map with a different theme, population density. Notice the countries are not quite as easily defined. This map cares more about you knowing where people live than what countries have what comparisons. If you're looking at the African countries, if you didn't know those countries, it would be kind of hard for you to pick out which ones are different. Same with Central Europe. Lots of small countries, hard to distinguish. However, you can see broad trends of where people live. That is the point of this map, and that's why it's made in the way it's made. This thematic map, we're going to see a lot through this chapter. It looks kind of funny, I get it, but it is a good map. This is a graduated symbol map, a cartogram, and what it does is it proportions the size of the country to the size of the population and keeps them relatively in the correct geographic area. Interesting side takeaway from this map. Take a look at this. Can you figure out where the publisher of this map is originally from? I'll give you a hint. Look at the countries and think about how close they are to their actual shape. Geography isn't just about looking at old maps. Recent technological advancements such as Geographic Information Systems, or GIS, the Global Positioning System, GPS, or remote sensing, have led to the development of the geospatial revolution, as the book likes to call it. I've never heard that phrase before. This is the use of computers and satellites to create more interesting cartography, essentially. GIS, or Geographic Information Systems, allow you to look at the particular region you want in terms of simply the things you care about, using satellite data to, for example, create a layer on a map that just cares about vegetation because the satellite cares most about green, for example. Of course, we are very familiar with GPS. It's in all our phones. When was the last time you actually used a map to go someplace, right? And then finally, remote sensing. This is remotely sensing things on the Earth. LiDAR, radar, aerial photography, things of that nature. These are all subdivisions and branches of geography that you may use in your career going forward after this class. They're not going to be touched too hard upon in this class, however. It is very important, I would argue, to understand these technologies and how they're used and how to implement it, and how really they've changed the world we live in. On the previous slide, I talked about GIS, or Geographic Information Systems, using layers. This image is an example of that. Here we have a suburb and a city center that's bisected by a river. We can take the information and we can build it into layers to properly describe what's going on. Notice the top layer would possibly be buildings, I could assume, focusing maybe on small buildings like the suburb houses. A step down, we have the roadway. There's a layer that just describes the roads we're talking about. A layer below that, maybe noise density could be an example, pollution perhaps. A layer below that looks to be some sort of elevation map. And then we can step further down and we can just have the squares that represent what's going on. We have your orange for your suburb, your dark gray, I guess I'd call it, for city center, blue for ocean. And these layers take that very complicated looking map picture in the bottom and break it down into things that you may care about. If the only thing you care about for what you're doing is the roadways, you don't need to have those pictures of all those cities there, right? Of all those little tiny houses. You care about the roads. Let me take the layer of the roads, extract the information out, and then I can use it to fit my needs. Geography is a growing career. Technology has expanded the opportunities and the uses of cartography from your old-fashioned making maps to cross the Atlantic in your Christopher Columbus boat to many different modern applications. Geographers, geoscientists, cartographers, urban and regional planners, geographic professionals, things of that nature. The U.S. Department of Labor identified geospatial technology as one of the most important emerging evolving fields in the technology industry. Personally, I've used GIS and geography in my geology studies. I want to go to an area, I want to find a particular rock bed that is of use to me. I'm going to go into GIS, I'm going to look at satellite data, I'm going to zoom in, I'm going to try to find where the rock crops are that I want to look at, so I don't have to wander around this area for a day, wasting a day I could be using to study the geology on finding the geology in the first place. I can pull out the layers that matter to me, and I can zoom in exactly what I want. I can create a map that fits my purpose. This is the modern application of geography. This is the real world benefit. And of course, I can always fall back to GPS. You know GPS is useful. You probably use it, I don't know, once a month at the very least to get someplace. You want to go to a friend's house? Do you really pull out your Rand McNally road atlas to try to find this house? No, of course not. He tells you directions, take a left at the gas station. Do you even look for the gas station? No. Pull up your phone, punch his address, Google Maps will take you right there. Modern, real-world application of what this class is going to be about. Since this is a geography textbook, they really want you to have an inflated understanding of the uses of geography. Those of you taking this class, I don't know if geography is going to be necessarily 100% applicable to whatever you end up doing for the rest of your life. Sure, maybe some of you want to be science teachers, in which case geography is going to be very important to you. Maybe some of you are going to work for, let's say, the USGS. That could be of use. Nature Conservancy Preserve Manager. I don't even know what that is. I'm sure they use geography all the time. Cool. But I do want you to come away from this class with an understanding of not only how geography is used, but also why it is important. That, I think, will benefit you beyond simply the rote understanding of the countries and the regions that we talk about in this class. Of course, any geography class worth its salt is going to tell you about Google Earth. Google Earth is just the best. It is a program that allows you to look at basically anything you want in the world in pretty good resolution for free. You could tell by this picture, this textbook is dated, but Google Earth is still, I would argue, the primary tool used by anyone that utilizes any variant of geography. If you want to get more in depth into these tools, another free program is called QGIS. That I'm going to suggest only if you're in depth and really want to understand how geographers and all those people listed on that last slide use this science. Well, I'm not going to have you dig into Google Earth to do what we're doing. This class is very much more so focused on the people and the politics of the regions involved than on drawing maps necessarily. But please, if you've never used Google Earth, at least take a scan through it. It is amazing. And if you're into astronomy, they have Google Sky. That is also just ridiculously cool. Congratulations, you have finished Chapter 1. If you have anything at all to say of interest, please leave it in the comments. I will respond to these comments. We will hopefully give you a good quality understanding of geography. And see you in Chapter 2.